In this lesson, I will explain to you the concept of decision tree regressor. Before going to start by using the Jupyter notebook, first of all, I will explain to you the concept. So see here, as I have told you that in machine learning, we have supervised learning. Supervised learning is divided into regression and classification. Means if we have to make the model related to classification or regression, then we have to use the supervised learning. So decision tree regressor supports regression as well as classification both. That is why it is called the card. If someone will ask you what is card, a classification and regression. See, C for classification, R for regression. Tree is a predictive model which explains how an outcome variable's value can be predicted based on the other values. So what is the meaning of this? Suppose this is our data set. Whatever we have on x-axis, whatever we have on y-axis, these red and blue are the data sets. If I will ask you that draw the predicted line, right, it is not possible that you can make a single line which will cover all the points. This is for the linear regression. And decision tree regressor comes under the non-linear. So see, this is the non-linear. If I will ask you, okay, using the support vector regressor, which we had discussed in my last lesson, make a curve or an arc, again it is not possible that we can cover all the points of the data set. So what we do in decision tree regressor, we divide the data into subsets. So see here, this is our one subset, this is our second subset. Again, it is not necessary that this subset should be long compared to this. No, if you want, we can divide our data like this. So we divide our all the data sets into subsets, small subsets or small parts. Then whatever data we have in this subset, we take the mean or average of that data sets. Similarly, whatever data we have in this subset, we will take the average. Similarly, the average, this is just the dummy data. Now on the basis of these averages, we draw a line. So in SVR or decision tree regressor, both are non-linear, means we will get a curve, not the straight line. So in decision tree, we divide the data into subsets. Then we take the average of each subsets. On the basis of that average, we draw a arc or curve, whatever is our line. And I will show you how to do it. Here is simple example because decision tree is based on the tree structure. This is our root node or the parent node. Suppose if I will ask you that what will weather tomorrow, rainy or sunny? Suppose we split in rainy and sunny, right? Same thing you have to do here. This is rainy. If it is rainy, this is called the decision node. Then we have to take some decision whether we have to bring the raincoat, yes or no. If you will say yes, then here no. If it is no, this is the terminal node. And but if you say yes, then we have different options. Okay, whether we have to bring rain boots, yes and no, right? So in this way this tree works. So cart, I have explained to you that decision tree supports classification and regression, which comes under supervised learning in machine learning. So what does decision tree regressor do? Decision tree builds regression or classification models in the form of a tree structure, which I show here. It breaks down the data set into smaller and smaller subsets, while at the same time an associated decision tree is incrementally developed. Decisions tree can be handled both categorical data and the numerical data. So whatever I had explained is written here. I hope the concept is clear. Now we will move to our Jupyter notebook and I will show you whatever I said here with the help of some data. So same data file which we had used for SVR support vector regressor, we will use here. It is saved in our CSV file. You have to import the libraries. Libraries are written here. So here First of all, we have to import our data frame, our CSV file, then we will make our X and Y variables. After that, from sklearn, we have to import decision tree regressor, right? This is the important thing. So after importing decision tree regressor, we have to create the object. These are the points after importing decision tree regressor or after importing any class. We have to create the object fit predict graph, and we will check our score. So this is our data set. It is stored, so you have to write down the path in quotation. Executed, same data is here, experience and salary. And if someone will ask you which will give us better result, decision tree or support vector regressor, so decision tree will give us better prediction compared to support vector regressor. Here is the shape. If you want to check the shape, this is our shape. Because I had explained all these points in my last video, that is why I'm going quickly. Here you have to create the X and Y variable. This is our data frame name. Again, I have used ilog function. For ilog, you have to use the index here. If you will use log function, then you have to use the labels, right? So all the records I need in index 1, which is experience, and the last one shows I do not want salary. Executed, see only our experience is there. Same thing for salary. Now we want salary, so executed, this is our salary. So see, if 12 years experience, our salary is 7,500. If 1 year's experience, our salary is $1,000, and so on. This is very simple and dummy data. If you want to check the data types of our two columns, so both are integer, that is fine. Here we have to import decision tree regressor. So from sklearn.tree, import decision tree regressor. This is our class. After importing, we have to create the object, right? So my decision tree, so that is why dt underscore reg I have used, but whatever you want, you can use as a name of the variable or the object, but it should be meaningful. Then we have to fit, right? This object dt underscore reg means decision tree regressor dot fit x and y executed. So see, it's executed successfully, and these are the parameters of this decision tree regressor. If you want, you can go and read from sklearn. Now, our point is to visualize the data. So we have to visualize the data, whatever we have on X and Y axis. Y axis we have salary, X axis we have independent variable. Color is green. If you want, we can make it red. Marker asterisk, that is fine. And in plot, here X, and here you have to write down predict function with respect to X. So this is our object name. dt means decision tree regression dot predict with respect to x, and I said color. Okay, I can change the color, make it blue. And these are our labels. Execute it, and you will see how nice all the points are covered. Compared to, if you will compare with the support vector, which we did in our last lesson, how nicely our graph covers all the points, right? But as I told you that in decision tree we divide our data into different subsets, then we take the mean or average. So here, in order to make our prediction more accurate, what we have to do, we have to take another step, that we want the mean from this point to this point. We need a mean or average. From this point to this point, suppose these are our subsets, we want the mean of this. So mean of this, how to take the mean of these points? In order to do that, you have to write down only these two extra lines. We will make one variable x underscore grid, I said, np. This one is for numpy function dot arrange. Some students do mistake here, they by mistake they use arrange, ARR, so it's time consuming because they will get an error. So keep in mind, this is the range function with a arrange. Whatever value we have, minimum and maximum on x-axis, we have to consider. We are going to improve or enhance the resolution of our graph. So here is point 1, And here I will give you again some homework. Change this resolution, make it zero point 0.2, zero point 0.3, zero point 0.4. Then you will see clearly difference in your graph. Again, you have to reshape this line with respect to length function and write down these two line as it is. What is the meaning of these two line? We are going to enhance the resolution of our graph in order to get the accuracy of our prediction. And then same thing, we have to make a plot between x and y. Here you have to use x grid, right? Instead of x, now we have x grid, and prediction is same. See here, prediction in our, here we have used dt means decision tree reg dot predict with respect to x. So same thing you have to write down, but here you have to use x grid. Everything is same. When I will execute it, you will see now is this is the average between these 2 points, and this will give us accurate result. Right, so now I will show you that dt reg predict 12. If we want to predict that, if we have a 12 years experience and I show you that salary is 24 7500, so here is the 7500. If you want, you can go here and check 12 and 75. If it is 1, then it should be 1000. Right, our model is so great. Right, sometimes it will close to 75, maybe 7450 or this, but this model is too accurate. See, 1000. If you want to check the score, so check score should be 1 because all figures are too accurate, that is 1. Right, so compared to support vector regressor, decision tree regressor gives us accurate result. This is too accurate, but after that we will discuss random forest, which will give us also the accurate result. But here we have one, that is why our result is accurate. Suppose if it is 990 980, that is also fine. But if we make the comparison between the support vector, decision tree and random forest, so random forest will give us more accurate result. Right, so I hope the concept is clear. It is very simple. Please practice it. If you have any question, you can ask me. Subscribe to my channel, share my channel, and thank you so much.